This is the case of a European patient implanted with a single chamber ICD who received an electrical shock while operating a power saw in the rain. This tracing is suggestive for electromagnetic interference, EMI. You can still visualize the R wave and the T wave, but you see also these very fast signals that saturate the baseline and that are oversensed. So here the VF counters are filled with a charge of the capacitors, and at the end of the charge a shock is delivered. You can see that it is the end of the oversensing and of the interference as well. The potential risk of interaction between electric systems and implantable cardioverter defibrillators has been frequently reported. EMI can occur in a variety of settings within and outside the hospital environments, at home, work, and other everyday environments. EMI may occur by conduction, if the patient is in direct contact with the source, or by electromagnetic induction, if the patient is positioned within an electromagnetic field. The diagnosis of EMI is based on a history of exposure to a source at the time of the event and oversensing of characteristic, very irregular signals spanning the intercardiac cycle. EMI at power frequencies of 60 Hz for the US and 50 Hz here for Europe occurs when the patient is in physical contact with ungrounded electrical equipment. If oversensing is prolonged, a single shock is most of the time curative, since, like in this example, the patient stops immediately the provoking activity, which then stops the interference. If you want to confirm that this interference corresponds to an EMI at the power frequency, you can change the sweeping speed from 25 mm per second to 200 mm per second, and then you can recognize the very characteristic sinusoid aspect of this interference. And since it's a European tracing, it's 50 Hz. If you measure the signal, there is going to be 20 milliseconds between each of the signals. Another thing that you need to check in this patient is the amplitude of the signals. So if you adjust the gain on the ventricular channel, you can see here it's 10 mm per millivolt. If you program 1 mm per millivolt tracing, you can see that one of the problems in this patient is the low amplitude of the R wave. Since the amplitude is low, the device will work with a high sensitivity all along the cardiac cycle. That increases the risk of any oversensing, and in this example, of oversensing of electromagnetic interference.